Hi guys, this is Ankush and welcome to my YouTube channel. In this video, we will discuss about representation of a set. As you have seen in previous video, we have discussed about the notation for a set and the proper definition of set in mathematical way and in natural way, both way. Okay. So we start representation of a set. Representation of a set. How we represent a set in mathematics? Okay, in generally we can speak a set anyway, but there are special kind of way to represent a set, and there we have two methods to represent a set. Okay, number one is roster form. Roster form. In roster form, we write the all elements of a set separated by commas and enclosed in brackets. Okay. What type of brackets? This type of brackets. This type of brackets. In these brackets, enclosed in these brackets and separated by commas. Comma. For example, we have, as you know, we denote any set by capital letter. Let's we have a set of vowels in English alphabets. Okay, so we represent this set by this as bracket start A, comma E, comma I, comma O, comma U and bracket close. Okay, we represent any set in this form. This method is called by roster form. This is roster form. This form is called by roster form. Okay, we write all elements of a set. Another example we can take here B, set of natural numbers less than 7, less than equal to 7. Okay, how we represent this set? We represent this bracket start 1 comma 2 comma 3 comma 4 comma 5 comma 6 and comma 7. Okay, we represent this as 1 2 3 4 5 6 separated by commas and enclosed by these types of this type of brackets. Okay, the next way we have, the next form we can have set builder form. Set builder form. In a roster form, we write all elements of a set. We write all elements of a set separated by commas and enclosed in brackets. Okay, but in set builder form, we don't write all elements. We write a formula or a condition under which the elements are added in our set. Okay, for example, if we take example A, set of vowels as set of vowels. In roster form, we write this as A, E, I, O, U. Okay, but in set builder form, we do not need to write A, E, I, O, U. We know, okay, we write the condition or the formula under which the elements are coming in our set. Okay, so we represent by a variable. We write and enclosed by same type of brackets. Bracket start. We write x, a variable. We can say x variable. Okay, x such that this symbol represent such that x is vowel. Okay, we represent in this type x such that x is vowels, or we can represent here x such that this symbol also such that, okay, x such that x is vowel, okay, these symbol are such that symbol, okay, we represent in this method. And we can write here, we write here condition, we can write here formula if we have given formula for a particular type of set, okay. If you write here set B, n belong to n, this symbol is belongs to, and this denotes natural numbers. N belong to n such that n less than 7, okay, and or we can write this as n such that n is natural number and n less than equal to 7, we can write this as, okay. If we see their elements, what type of elements are in the set? N is a natural number. Natural number start from 1, as you all know. Natural number start from 1 and natural number less than 7. So 1 we take 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7 and bracket close, okay. So we represent a set in this type, in this 2 by 2 method, okay. A roster form, this is our roster form, okay, and this is our set builder form. Set builder form, okay. So we can represent our set in 2 by 2 methods or in 2 way, okay. These are the 2 methods, okay. And we have an important thing in the sets, we write as note the order of writing the elements, the order of writing the elements is immaterial, okay. ये मैटर नहीं, it doesn't matter how we write, what element we write first and what we write it last, okay. So we can write this set as 7, 3, 4, 6, 1, 2, 5, okay. We can write the same set as this. The order of writing the elements does not is immaterial, doesn't matter, don't matter how we write the elements, okay. And the another thing is that we cannot repeat the elements, okay. We cannot write here 7 7 7 3 4 6 1 6 7 1 2 5, we cannot write as this, as it, okay. So we can write 7 only once. Any elements of a set can be written, must be written once only. These properties are for our set, our tabular form or roster form. We call roster form as tabular form also, okay. So any elements of the set is not written more than once, okay. So next our is type of set. There are there are basically 2 type of set. We can divide a set. We can divide sets in 2 type, okay. The one is finite set and another is infinite set. Basically we divide the set, we divide or we classify the set based on their number of elements. Okay, we classify the sets based on their number of elements. We see that how many elements are there in a set, and we say that a special type of set. Okay, as you are seeing here, finite set and infinite set. Finite set means finite set, a set in which the number of elements is finite. The number of elements are finite. Okay, a set in which number of, we can, this symbol is denoted is for the number of elements are finite. Okay, a set in which the number of elements are finite, we call finite set, we call it finite set. Okay, and other is infinite set, oppositely infinite set. A set in which the number of elements are infinite, we can, for example, we can take here, we have discussed the example, natural number less than equal to 7 are finite, or the number of or the set of vowels is finite, because there are 5 elements in this set A and there are 7 elements in this set B. These are examples of finite set, and you can make more examples in nature around you, many examples of finite set. Okay, and infinite set, we can take the set of natural number, a set in which the number of elements are infinite. Okay, for example, set of natural number, set of natural number, set, we can take set, there are so many sets which are infinite set of real numbers. Okay, set of whole numbers, set of rational number, these all are sets are infinite set. Okay, and now we define special type of sets. Number one is empty set, or null set. Okay, what do you mean by a null set or empty set? A set in which there are no elements. Okay, a set in which number of elements are 0. A set in which number of elements are 0, there are a set in which there are no elements. Okay, we can take example, set of natural numbers less than 1. Okay, we know that the natural number are starts from 1 and goes to infinity, 1 2 3 4 5 6 7 8 9, these type. Okay, but here what is he saying, set of natural number less than 1, and we know that there are no natural number which is less than 1. Okay, there are no natural number which is less than 1. So the set, if we take the set A is empty set, or we can call it null set. Okay, and we represent a null set or empty set by this symbol phi. Phi. Empty set is denoted by, we write the elements phi here, only on phi. Okay, and the next is singleton set. Singleton set. Okay, a set which contains a set which contain only one element. Okay, and in case of empty set there are so many examples. We can take natural number less than 1, or we can take positive integer less than 0. We can take another example. Set of positive integers less than 0. There are no positive integer which is less than 1. Okay, we know already. So this set is also empty set. Okay, singleton set, a set which contains only one element. Okay, and null set, a set which contains no elements. Okay, we can define we can take example of this singleton set. We can take a set A, set of, I think you are borrowing from natural numbers, so we must take any another example. So we can take here, there are so many examples of singleton set also. The country, the set of country with highest population. The set of CO countries with highest, we can take here population or growth or economy, etc. things. Here the main thing is highest. We know that at highest level, only on one country, or at highest economy, there are only on one country. No, 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 no. This example can be wrong, because there are two countries which are equal in many things. Okay, so we can take here any other examples. Okay, okay, we take a funny example. We can take here set of fathers. Okay, set of fathers of two set of father of a set of father of Ritik. We can take here set of father of Ritik. Naturally, there are only one father. There are only can be one father and one mother of any students. If we any children, if you take as basis on DNA. Okay, and if we take another basis, which parents studied him, or which parents grow him, in any other cases we can take so many fathers. But by actual, the basically by DNA test, there are only on one fathers of any children and only on one mothers of any children. Okay, this is singleton set. Okay, set of fathers of Ritik, set of fathers of Ritik. And we can take here set of president of a country. set of presidents of a country. We know though that there are only on one president of a country. Okay, and the second one is vice president, not president. Okay, so this is also a singleton set. Today we will stop here. Okay, I hope you understand it. And your homework, if you do, if you want to do homework, the homework is to make examples of five examples of each type of set: finite set, infinite set, singleton set, empty set. Okay, and write them in both way, roster form and in set builder form. In both form write them. Okay, so thanks guys, thanks, bye bye, tata, take care.